Hi beautiful people, welcome to my channel. My name is Busisiwe Dlamini Kharodi, the campaign principal. If you haven't subscribed already into my channel, may you please click the subscribe button there at the bottom and also click on the notification bell so that every time when I upload a video, you will be notified. So today we are going to talk about Beer's law, which it is the law that the spectrophotometric principle usually uses, or colorimetric uses a Beer's law for us to be able to get a result of a patient. So what does Beer's law say? So Beer's law says when a monochromatic light of a specific wavelength passes through a cuvette containing the patient sample, the concentration of the analyte that is in the patient sample, it is directly proportional to the absorbed light and inversely proportional to the light that will be transmitted. So monochromatic will mean mono means one. So a light with a single wavelength passes through a test cuvette containing a patient sample. Some light will be absorbed and some is transmitted. So the concentration, I will use this to represent concentration of the analyte, is directly proportional to the absorbance and inversely proportional to transmitted light. So if you still remember how the components of a spectrophotometer, they sit in the spectrophotometer, you'll be having your light source, and there's your monochromata that's going to select a specific wavelength, and then that single wavelength that is required for that analyte will pass through a test cuvette. So if that analyte that is inside the test cuvette, it's in higher amounts, it means what it will do, that analyte will absorb the light, and then you will find that now the light that reaches the detector, it's less. Then it means now you're going to have an increase in absorbance. Or if you don't have any concentration of that analyte in the test cuvette, it means now that light that will be shown through, which is monochromatic and that is specific for that analyte, inside the test cuvette, there will not be anything that will absorb the light. Then it means more light will be transmitted. So more light will reach the detector. Then it means you have a decrease in absorbance. So basically what Beer's law says, it says that the concentration of the analyte is equals to absorbance. So it means the higher the concentration of an analyte in a test cuvette, it means the higher the absorbance. So basically then we can be able to use this law or this rule to be able to determine the amount of concentration. I will show you how just now. So if now you when you have by this inversely proportional to transmitted light, what we mean is that the more light transmitted, it means the lesser the concentration. The lesser the light transmitted, it means the higher the concentration, because the light will either be absorbed or transmitted. So when you have an increased concentration of the analyte, it means more light will be absorbed and less light will be transmitted. So that's what basically what Beer's law says. So there is two ways that we usually use in the laboratory to determine the concentration of an analyte by using Beer's law. One which will be by a calculation, and another one will be by using a calibration or a standard curve. So let's start with an example with a calculation. We present this Beer's law in a formula. It is the absorbance of an unknown, which is going to be U. So now the unknown will represent your patient sample, because you don't know the concentration of that analyte in the patient sample. It's divided by the absorbance of a standard or of a calibrator, which will be equals to the absorbance, the concentration of an unknown over the concentration of a standard. So it means if you know the absorbance of an unknown, like we said, absorbance is equals to concentration. Can you see? Then the absorbance of the standard is also equals to the concentration of the standard. So now what we would usually do, we'll rearrange this formula so that we can be able to get the concentration of the unknown. Because with the spectrophotometer, we can measure the absorbance. So that's the only, there's no instrument that can measure like specifically a concentration of an analyte. So in this case, we are measuring absorbance, and when we know the absorbance of that sample, then we are able to determine the concentration of an analyte. So to rearrange the formula, it means we want this concentration. Okay, so to make the concentration of an unknown the subject of the formula, what we can do is that we can multiply by the concentration of an analyte on both sides, because with mathematics, whatever you do on the left hand side, you must do on the right hand side, and then this will cancel that, and then now you'll be left with that the concentration of an unknown is equals to the absorbance of an unknown divided by absorbance of the standard multiplied by the concentration of the standard. So to write it nicely so that we don't get confused, you can say Cu is equals to unknown over absorbance of a standard multiplied by concentration of the standard. To be able to remember, because I know most students, they like to swap this around, putting the standard on top or and the unknown at the bottom. To always remember this, I always say rather think of us. So when you think of us, U comes before S. So it means U will be on top and S at the bottom. So now you have your formula that is complete. So now let's say you have a question, or you're in the laboratory, you find that the absorbance of your standard, let's say it's equals to 150. And then absorbance of your sample is 200. And then the concentration of the standard is 3.2 millimoles per liter. To give you a tip, in a chemical pathology board exam, every time when you see a value that does not have a unit, think about absorbance. As you can see, we just say 150, 200. But when it comes to concentration is 3.2 millimoles per liter. So in most cases, even if they don't tell you that is the absorbance, if you find a value that does not have a unit, then you must start thinking of absorbance. So as soon as you have all the information that you need, now you can be able to substitute it into your formula. So you'll say, okay, the absorbance of an unknown is 200 divided by the absorbance of the standard, which is 150, multiplied by the concentration of the standard is 3.2 millimoles per liter. Then you're just gonna punch this into your calculator as it is. which gives us the value of 4,3 millimoles per liter. So whatever analyte that you were calculating, so let's say we were calculating calcium, so it means calcium in this patient sample is 4,3 millimoles per liter. So this is one way of using Beer's law to be able to get the concentration of an analyte. And then another way of using Beer's law, as I've mentioned, to get the concentration of the analyte is by using a calibration curve. Or a standard curve. So in this case, we will be talking about, because we said they are directly proportional, so we'll be talking about a linear graph. So what happens is that each and every instrument, it will depend on the lab's policy or on the supplier's policy, but before you can use the instrument will have to be calibrated. What does that mean by calibrated? When you calibrate, basically you are standardizing that instrument. So what do we use? We use a calibrator, and a calibrator is a solution with a known concentration already. With some analytes on certain instruments, you will find that you will have maybe 6 calibrators with different concentrations that will aid into plotting the graph. But with some, you'll find that you only have one concentrated solution, which will have that known concentration, and then when you put it in the instrument will make its own dilution, because you can't draw a graph with one point. To make various points so that the graph can be drawn. But basically, this is how the graph will look like, which on the y-axis you'll have absorbance, and on the x-axis you'll have the concentration. So in this case, what we'll be having, we will be having here, it will be 0. So let's say your concentration, this is 2, 4, 6, 8, and then the unit is millimoles per liter. And then with the absorbance that we got on the spectrophotometer, when we were testing these different concentrations of the standard. So what we got is that when the absorbance was 100, the concentration of the standard was 2 millimoles. And when the absorbance was 150, the concentration of the standard was 4 millimoles. And when it was 200, the concentration was 6. And when it was 250, the concentration was 8. So this is the graph that we will have, or this is the graph that the instrument will have at the back or in its programming after a calibration has been done. So now what happens is that when now we have a sample that we don't know its concentration of that analyte. So what happens is that the sample will be measured, and the absorbance of the sample will be obtained from the spectrophotometer reading. And then once we know the absorbance, so let's say the absorbance that we got on the sample is 250. So what the instrument will do, will say, okay, with 200, if the absorbance is 250, it will draw a line where it meets that linear line, then it will go down, and then that will determine the concentration. So it means even with the sample, if it had an absorbance of 250, it means its concentration will be 8 millimoles per liter. Or if let's say the concentration was 120, still it will do the same. Let's say here it's 120, that's the absorbance. Then we'll draw the line where the line meets, then it will go down. Okay, it means the concentration is 2,5 millimoles per liter of that. So this is how you can also get the concentration of an analyte by using Beer's law, by using the calibration curve that is linear. So that is it for me from this video. I wanted to talk about Beer's law and how we can get a concentration, and we have covered that. Hopefully you do understand, but if you have any questions that you need to ask me, may you please put them down there on the comment field. And then if you want to comment, or if there's anything that you need, just put it there. I will interact with you. And if you need assistance with your board exam prep, I'll also put my email down there. That's it from me for now. Up until next time, bye.